Alright guys, please confirm if you can see me properly. Alright, please confirm in the live chat. Alright guys, good morning and welcome. Please confirm in the live chat. Yes. Okay. Alright, good morning guys, good morning. I think that right now I am visible and you can see the slides also. Tell me, confirm guys, yes or no? Good morning all of you, welcome. Yes, so right guys, we are going to continue our discussion on organic reagents. And there is a very important thing that I want to discuss for all the upcoming exams also, that is your 30th November Tamil Nadu exam. Yes guys, very good morning. Very good morning to all of you. So yes, for the Tamil Nadu exam also we are going to discuss important stuff. That is, in this exam you must have already seen the analysis session, right? I have it on my channel, I have it on Unacademy as well. I have taken a special class on Unacademy yesterday night at 8:30 p.m. Alright, so we had done some analysis for around 37 questions in detail. Alright, so yes, what I have seen, what I have observed in this for this exam is that we are having more conceptual questions that, for example, are that you get in your theory exam or something like that. Okay, so there were less of the questions which can apply a simple trick and it is done. They are not like that. They are more conceptual questions and include a lot of reaction mechanism. Okay, so they include a lot of understanding of the reaction mechanism. So now this becomes the most important part of organic chemistry. Good morning everyone, welcome. Yes, once again. Alright guys, so before starting our question practice, we will be doing some question practice. The June 2021 exam is done. Alright, but we are heading towards the GATE 2021 exam as well. Okay, so that is another great opportunity for all of you to get your funding for the PhDs, right? So we are heading towards the GATE 2021 exam. We have to take in some observations about the ongoing exam pattern right now. Yes, and what is that the more conceptual questions are getting asked. That means for to be able to answer questions on organic chemistry, you must know the important concepts. Okay, and you must have done, or you must have gone through some of these book examples. Okay, so this has already been there. Book examples have always been important, but at this point of time, the book examples are really important. And the concept is not just one thing. It's not always there have been mixing of concept for the questions, but this time it is more mixing with the reaction mechanism. Okay. Yes, so what we are going to do is we are going to solve some organic reagents question which are more oriented towards the reaction mechanism part, and this is specifically for the Tamil Nadu exam, right? Because I think that these questions are going to be favorable than just directly learning that what is LiLH4 going to do, what is NaBH4 going to do, what is Luce reduction. All right, so directly not jumping onto that, we are going to solve some really good question. Okay. Yes, so now before moving onwards, guys, yes, definitely Rudra. So we are discussing this before moving onwards, that what is the plan for June 2021 and GATE 2021 exam. So what is the plan for June 2021 CSIR NET exam? Okay, and what is the plan for the GATE 2021 examinations? So what we are doing, guys, first thing first, we have already discussed the important theory in our CSIR NET courses. Okay, the theory is already discussed. Now we are going to practice questions for the GATE exam. So we are going to solve the previous year questions, as well as we are going to solve some new conceptual questions. Now these conceptual questions are made by us so that we ensure ki chalo, okay, that you are getting some idea of what could be asked. So this course, Practice Booster for GATE, is a batch course by 3 educators, and we are covering all the important topics for GATE. Okay. Yes, so we are covering all the important topics for GATE. It is starting from 1st of December. Now moving onwards, guys, from 1st of December itself, we are starting another new course. Now this one that you see is a batch course. Focus CSIR NET June 2021. This is a batch course by me and Nurul Huda sir. The first class is on 30th of November itself, but the Tamil Nadu students would not be able to attend it. So you can watch that recording later. You can start from 1st December also. Okay, so 1st December, say we are starting our new batch because we have 1 month extra. So we are starting our new batch, beginners course on chemical sciences for CSIR NET June 2021. Okay, so usually we have 6 months. This time we have 7 months, guys, and this is very important for all of you to utilize your 1 extra month. Okay. Yes, so this is our preparation for the extra month. We are going to start from the very important topics. I am taking complete organic plus complete inorganic. Okay, so in these courses, you will see the schedule till December to March. In all of these 5 courses that you have a GATE practice course which is completely based on practice and revision. In the other courses, like over here from December, then January, then 5 February, and then 23rd February. So you are going to see the schedule for December to March only. Why? Because here we are doing our study. Here we are doing our theory study along with a little bit of practice from the mid of April, guys. Okay, so from the mid of April, we are going to start launching these revision courses. So those courses will be launched before 1 month of the April, right? So revision plus PYQ practice plus new question practice. Alright, so these all courses are going to start from mid of April. Okay, so that is why we are going to launch them later, but now we have December to March schedule that you can see, in which we are doing all theory, all conceptual study. All concept study we are going to do, and these courses you can see if you are already there on Unacademy Plus, you have to enroll in all of these courses, and I am specifically taking complete organic and complete inorganic in the batch course. And in this batch course, as you can see, Nurul sir will be taking complete physical chemistry and the inorganic as well. Okay, so he will be teaching physical as well as inorganic. So this is going to be really beneficial, guys. Before this exam, inorganic was tough. So we are doing, both of the educators are doing inorganic chemistry, and individually we are doing physical and organic. So you're getting the complete syllabus and all the important topics for your upcoming June 2021 examination just by following two educators. Just by following two educators. But there is one more thing that I want to tell you, which is a common misconception, that by using the referral code of any one of these educators, guys, you are getting the access to all CSIR content. All CSIR educators. Okay. All the CSIR educators under just one subscription. That may be your life science, physical sciences, aptitude, everything you are getting. Okay, so no restriction on that. So here we start, guys. For example, if you are taking the 12-month subscription, that is going to cost you something around 11,550. If you apply the referral code, that reduces to 10,395. If you apply your credit points that are earned by watching more free classes, then you have 9,356. So basically, roughly telling you, for 12 months you are getting the access, you are getting the plus access to all the CSIR net educators for approximately around 10,000. It could be less if you are having a greater number of credit points. So this is how it works. Okay. And yes, also there is one more thing, that if you are subscribing now, for example, if you are subscribing on, let's say, 5 December or something like that, you will be able to access all the previous courses, all the previous free classes plus classes, whichever are there on the platform. So all recorded sessions, all are recorded sessions, so no worries at all. You can join whenever you want to join. Just that if you are joining too late, there will be a pressure which is developed because of the pending classes that you have. So that is why we suggest all of you to start from 1st December itself. We don't want to pile up things, isn't it? So that is only my only reason that I am telling all of you to subscribe now. And now, guys, we are going to begin our question practice. See, the questions were, once again repeating, the questions were very conceptual, and most of the times the things were easy, but there was regioselectivity, stereoselectivity. So once again, I have taken a question on a similar ortholithiation reaction and talking about the regioselectivity. So what do you say? What is the major product formed in the following reaction? And guys, also, if you're having any doubt regarding the subscription, you can message me on Telegram, or you can message in the group as well, CSIR NET 2020. You can message me in the Telegram as well. Okay. So what do you think is the answer to this question? Secondary butyl lithium, it's a bulky base, TMEDA. So as such, there is no role of TMEDA. It is just there to stop the aggregation of these alkyl lithium, so that you can properly use your alkyl lithiums in the organic solvent. Yes, what do you say? So this is definitely an ortholithiation reaction. Definitely our ortholithiation reaction, but where is it taking place? Either here, or on the nitrogen itself, or on one of the methyls of nitrogen, which is going to be the most acidic proton to be removed by butyl lithium. So since the nitrogen is not as such having a positive charge or electron deficiency, these two methylene protons are not as acidic as the aromatic protons over here. Okay, so this is what we have to know, not as acidic as the aromatic proton. And also we are not going to go with this product option number C, because it is not the para-lithiation that we have ortholithiation. So nitrogen methylation not possible. Once again, this is also not possible, methylation on nitrogen. So we end up with option number B. Okay. So this is a reaction of ortholithiation from your previous year questions. Try and do, for all Tamil Nadu students, try and do all the ortholithiation, or let's say regioselective reactions, as many as possible. Okay. Now here we are. The major product formed in the following transformation is what is the major product of this reaction? All right. Easy question. Once again, the stereo and the regio is of utmost important. Yes, nitrogen के पास वाला ज़्यादा acidic होना चाहिए. Okay, but that will happen when the nitrogen is electron deficient. Okay, so if there is some positive charge on nitrogen, or let's say more electron deficient, then that reaction would be more preferred. Now moving onwards to stereo and regio selectivity, what do we have, guys? We have methyl magnesium chloride. You have the Grignard reagent, which usually gives you the 1,2 product, but in the presence of CuCl you get the 1,4 product. So you must have this knowledge of the direct and the conjugate addition. Many a type of question on the direct and the conjugate addition have been asked in this paper also. Okay, so here we are. Let's just talk about this. For example, if you are doing you have the methyl cuprate synthesized, for example. Okay, then not the Li, let's say magnesium we have. So methyl is actually becoming a soft base, so it is going to give the 1,4 addition like this. Alright, so if it gives 1,4 addition, let's say for example the phenyl is above. For example, the phenyl is above, then the methyl must have added below or something. Right. Now after this reaction, when I have the attack of enolate onto this allylic carbon, then what do I see? What is the preferred stereochemistry that you know? That the allyl group is going to go away from the more hindered group. So here the phenyl is the more hindered group. Yes, the phenyl is the more hindered group as compared to the methyl. So hence what we do is we take our allylic group below the plane like this. So your answer has to be option number D. Exactly, this is our correct answer. So now stereochemistry in regio is of utmost important once again, and let's now move onwards. Another regioselective reaction. Another regioselective reaction. Yes. The major products A and B of the following reaction sequence are alright guys, so what do you expect in this question? Once again, very very important. So phenyl magnesium bromide, you don't have the possibility of 1,4, so you have the direct addition. Very well. So this is what we can say about it. Let's say you have O minus or OH and your phenyl group is connected like this. In the second step you have tosyl. Alright, so this is your toluene sulfonic acid actually. So that gives you elimination. What elimination do you expect, guys? In the presence of an acid, you are going to get this kind of an elimination product. There is this phenyl group and then is the double bond. Alright, so this is very very important. You have generated an alkene. Okay, so alkene is there in option A, B, A, C and D. It is not there in option B, so we are not going to consider this. Okay, this is not what we result into. After this reaction, you see that there is hydroboration but no oxidation. Hydroboration like this. So your pH, let's say it is going to go above the hydrogen added from below, and because it is syn addition, we have the BH2 also added from below. But we have to get the oxidation also, even if it is mentioned or not mentioned. So we have the phenyl above the plane and then we have the OH below the plane. But we don't much care about the stereochemistry because in the next step there is PCC oxidation of the secondary alcohol. PCC oxidation of the secondary alcohol gives you a ketone over here, and once you have got the ketone, the last step is your, what is this last step, guys? Ketone to ester or ketone to lactone. What is the name of this reaction? It is the Beer-Villiger oxidation. Okay. Definitely Disha, it is going to help GATE 2021 as well. So guys, be very careful about the metachloroperbenzoic acid, because you know that oxygen is going to get inserted. Like in where? Is it going to get inserted between this carbon and this carbon, or the more substituted carbon and the keto carbonyl? So definitely the oxygen gets connected in between the more substituted carbon like this, not on the less substituted carbon. So even this product is wrong and even the intermediate was also wrong. So B is a completely absent option. This is not going to be. Your answer is option number A. The third reaction that we have, metachloroperbenzoic acid, this is our Beer-Villiger oxidation. So we are not having epoxidation, we are going to have the oxidation of ketone to lactone. So A is our correct answer. Yes guys, what do you think? See, if we did not have PCC oxidation, agar PCC oxidation nahi hota, and if we, let's say, had the alkene only and no hydroboration, then you could form the epoxide. But since you have alkene reduction, or let's say BH3 addition, hydroboration, oxidation, and then PCC oxidation to give the ketone, you are perfectly sure that you are having the Beer-Villiger oxidation. So A is our correct answer. Okay. Now guys, we move onwards to another very important question. The major product in the following reaction sequence is, very important examples of enolate chemistry have been asked this time. Enolate chemistry is extremely important. Alright guys, so yes, please comment what do you think about this reaction. Ozone has been asked a lot of times, this time also. It was given in the paper. What is ozone going to do? It is going to cleave the carbon-carbon double bond, isn't it? Ozone cleaves the carbon-carbon double bond. So first of all, we have to see where can we get a carbon-carbon double bond. Here is your acidic proton on the alpha carbon. Here is your triethylamine base, which is going to abstract this proton, and then you get the negative charge on oxygen. Guys, if you get the negative charge on oxygen, it is going to be O minus, and that O minus is going to attack on the trifluoroacetic anhydride, which gives you COCF3. Okay, so protected oxygen over here. Now this is where you get the double bond. Yes, right, very good. Now working with ozone. Alright, so oxidation with ozone is going to give you this kind of a product where there is OCOCF3 and a new double bonded oxygen has formed on this side. So this is what your product is going to be. Now there is one more thing. Since you have Me2S, there is going to be reduction, but you see that this bond could open away and the carboxylic acid bond could attack on this carbonyl to give you an alcohol. So basically guys, your product must be something like this. Double bond O and oxygen over here, 1, 2 and 3, 1, 2 and 3, like this, and there is one methyl group and there is one OH group. Okay, so it must be something like this. Even if you want to do if you want to carry out the elimination, it could be like this. It could be like this, elimination in the presence of acid, to give you option number B. Okay, so definitely guys, if you are breaking down the alkene, you are going to get two ketone, or let's say the aldehyde groups. But since there was already one oxygen present over here, getting a new oxygen by breaking this bond is going to give you a carboxylate anion, okay, which gives a tax on the ketone to give the product like this, and this is O is going to become OH. The removal of the OH is going to give you a double bond. So the answer is option number B over here. Okay, moving onwards guys. Very important questions all of these are. Let's talk about this reaction, sulfoxonium and sulfonium ylides. Yes, so they come into reactive intermediates as the carboanions. They are asked in your reaction mechanism also. So what do you think is the product of this reaction? The correct reagents for affecting the following reaction are yes, so alpha beta unsaturated ketone you have on one side, on the other side you have an isolated alkene system. So you want to get these three different types of products. Okay guys, tell me what is the correct answer. In the live chat you can answer. So your sulfoxonium ylide is going to be like this. Okay, and that gives you cyclopropanation reaction. Why? Because it does more effectively conjugate addition. More effectively it does conjugate addition. We know that already, yes. Then there is sulfonium ylide. Like this. So there is sulfonium ylide like this, and it is going to give you direct addition. And that means if you are having the enone system, guys, if you are having the enone system, then both of these are going to show different functions, right? So you have the enone system, the sulfoxonium ylide is going to give you cyclopropanation. Alright, so your A option is the sulfoxonium ylide that you have just right over here. Okay, then you move onwards to option B. I told you it gives you direct addition, which means that gives you the epoxide formation. So it is your sulfonium ylide in the second step. In the third step that you see, your isolated and more electron rich alkene. This alkene is isolated and it is also more electron rich. Alright, so Simon-Smith reaction believes, yes, Simon-Smith reaction always, whenever you see the examples, it always attacks on the more electron rich, so which is the isolated one. If you want to get cyclopropanation over here, that is your Simon-Smith reaction. So the answer is option number A. Exactly, very simple question. Answer is option number A. Moving onwards, guys, ये देखो, the major product formed in the following reaction is. So pyridines are very important. This time also we had, two reactions. I guess we had two reactions on pyridine. Okay, pyridine, lithium, liquid ammonia, tertiary butanol, then hydrolysis, and then third step KOH and MUH addition. So what do you think is the answer, guys? We have done this before in our classes. Yes, good morning once again. So the first step, guys, as you can see, is your Birch reduction. So what you can write down in the Birch reduction, let's say the electron is getting transferred onto the fourth position so that the anion comes on the nitrogen. So you can try and write it like this. Okay, this is going to be a more stable intermediate as compared to the other way around. So one more electron taken up by lithium and it is going to do the hydrolysis then. So your final product after the Birch reduction, it is going to be like this. Okay, and in the second step you have water, or let's say acid. So in the presence of acid, your enamine, this is an enamine, right? The enamine gets hydrolyzed in this manner. Alright, so yes, this is the way in which the enamine gets hydrolyzed. You have a new OH bond, there is a hydrogen, and then this is how it happens. Now when the oxygen creates a new bond, the nitrogen bond is broken apart. So the same thing happens on the other side as well. So what you have is, guys, okay, so there will not be this bond over here. There would be the carbonyl group and the methyl group, which is already present. So your molecule, after the whole hydrolysis, in the second step only, there is complete hydrolysis of the enamines or the imines, whatever you call it. So after we get the product is going to be like this. You have now two carbonyl groups and this methyl right over here from where there was nitrogen. Okay, complete hydrolysis. Okay. Now in the third step, it is the aldol reaction which is taking place, intramolecular aldol reaction. So you are going to generate enolate from this side over here and attack onto the other carbonyl in this manner, so that you get 1 2 3 4 5 and 6 membered ring. So your 6 membered ring is going to be similar to B and C, not in A and not in D. So it could be B and C. Now what do you see, guys? After this whole reaction is carried out, you have one methyl group on the end, onto this end carbon, and let's say this is what you have, और ये हो गया है OH. So your product has to be something like this. This is our major product. So definitely this methyl group must be connected to this carbon-carbon double bond. Here it is not. So your correct answer is option number B. It prevails. Okay, this is our correct answer. Alright, so we move onwards to another good question on organic reagents. Once again, conceptual question. Alright, conceptual question, more focused on the regio and the stereo once again. Alright. So yes, what do you think is the answer? So guys, the molecule is actually like this. Do you see this thing? The molecule is actually like this. Okay, this way the molecule is going to be, and both of these two rings are going to be below the plane like this. Okay, the molecule is having a butterfly kind of a shape. Okay, and the 6-member ring is below, the 5-member ring is below. If you think that from where the dibel attacks, dibel is giving you a hydride attack actually, so that gives it from above the plane like this, and the bond opens apart. So finally, what do you have guys? Finally, you have the O minus over here. Alright, so both of the hydrogens are above the plane itself. It becomes O minus, and then it is going to open up the lactone. Like this. Okay, it is going to open up the lactone. The stereochemistry is both below the plane. They cannot be above. Both of them are going to be below the plane. So this is what we understand from here. Very well. In the second step, you have another Grignard reagent. Now this Grignard reagent is actually like this. So there is a vinyl group which wants to attack the carbonyl, and that is going to give you the product like this. That gives you an alcohol actually. Aldehyde to alcohol conversion. Secondary alcohol, CH double bond CH2. A hydrogen, and this OH group. Now further guys, further what you see Pcc oxidation. Pcc oxidation is going to give you conversion of this alcohol into ketone. This is going to be converted into ketone. First step is the nucleophilic addition, second step is the Pcc oxidation. So you get a ketone like this, and then the OH is going to attack over here once again, gives you a lactol, like this. Alright, it gives you a lactol in this manner. And further what do you see? Alright, so either this equilibrium is possible, the equilibrium between your alcohol or like this, or there is one more thing possible. What is that possible thing? That you alcohol that you got from here, this could be oxidized by PCC. So this equilibrium looks like not happening very much. So why is this not happening? Because of the instability of the lactol. So further what do you get is, you get just the conversion of the where did we end? Alright, so we ended on this product. we ended on this product that you have the OH on this side and CH double bond CH2, and then you have the OH over here. So we ended on this product. Why is it not forming the lactol? Because that does not seem to be a good equilibrium. Finally, with the PCC oxidation of both the alcohols, you get a product like this. Okay, so there is a double bond O on this side, there is a double bond O on this side, and it is present in option number A. ठीक है, वन इक्विवेलेंट डाइबल है तो दूसरे साइड अल्कोहल कैसे फॉर्म हुआ? दैट इज गणेश, इट इज बिकॉज वी आर डूइंग द रिंग ओपनिंग ऑफ द लैक्टोन. लैक्टोन अगर ओपन होता है, एक साइड में मिल जाएगा एल्डिहाइड, दूसरे साइड में मिल जाएगा अल्कोहल. दैट इज हाउ इट वर्क्स. Okay, so yes, the answer is option number A for this. And again we are going to move onwards to see another good question. अब देखो एक और बहुत अच्छा क्वेश्चन है. मेजर प्रोडक्ट A and B in the following reaction sequence are PH3, PPH3, that is triphenyl phosphine, dead molecule, 2-iodophenol. That gives you option number A, and then further this reagent gives you option number B. So what do you say about this reaction? Is it the Mitsunobu reaction in the first step, 2-iodophenol? Is it the Mitsunobu reaction that you are carrying out? Yes, like this. Yes, दीक्षा लैक्टोन क्यों नहीं बना? ये देखो, चलो एक बार पीछे चलते हैं. लेट्स आंसर योर क्वेश्चन कि लैक्टोन क्यों नहीं बन रहा है. बिकॉज सी, इवन इफ इट इज़ गेटिंग ऑक्सीडाइज, ये वाला कार्बोनिल अगर ऑक्सीडाइज हो भी जाता है, then for the formation of lactone you have to remove this vinylic group. ठीक है? Yes, you have to remove this vinylic group, which is not possible. Okay, the removal of this group on oxidation and removal is not possible, hence we are not doing lactone formation directly. We are oxidizing both of the alcohols. ठीक है? So this is first step over here is your Mitsunobu reaction. And this is always going to be asked. Very simple question it is. Then there is an inversion, right? So these two are completely incorrect. Option number C and D, not so good. Then we move onwards. What is the next possibility? Okay, so the next possibility is your tributyl tin hydride and AIB. And what does that give? What does that give to you? Yes, carbon iodine bond opening, isn't it? So guys, then the next step is going to be radical cyclization. Okay, the next step is going to be radical cyclization, because first of all you have a phenyl radical. The carbon iodine bond is going to open apart. Yes, यहाँ पे bond open हो जाएगा. You get a new radical formed over here. Let's say I'm drawing it this side. Okay, and here is the alkene. So you get a new carbon-carbon bond formed, and yes, new carbon-carbon bond formed. And what happens is, ये देखो, radical cyclization in such a manner, that gives you exocyclic radical, exoradical. Okay, so hence the option has to be option number A. Why? Because we are forming a 5-membered ring on this side. There is a hydrogen which is already above. A 5-membered ring, hydrogen is already above. Hence, what do you see? That the methyl will also go above the plane, because a 5-membered ring likes to have the cis junction on the same side. So answer is option number A. बिल्कुल, वेरी गुड, ए ही आंसर है हमारा. Very good, all of you. Now we are going to move onwards to another next good question. Here you see major product formed in the following reaction sequences. Yes, Narendra. So tethering is basically the ring formation, the chain formation actually, and in the radical cyclization, it follows the Baldwin's rule and follows the exotrig radical. Exotrig radical it forms exactly. You have another good question. The major product formed in the following reaction sequence is. So guys, what do you say about this question? Yes, definitely. Yes, definitely we have to determine the stereo. Very, very important. So this is your alpha pinene system, isn't it? Yes, right. And these conceptual questions are very important. So yes, very good that your hydrogen is going to be added on this side and the BH2 adds on the other side. So if you want to write first of all that okay, this is your carbon above the plane. So there is a hydrogen and there is a BH2 over here, which is going to be below the plane. And on the oxidation, there is an oxidation step also. On the oxidation, you are getting this kind of an alcohol. Now methyl is above, hydrogen is below, and this OH is also below the plane. But once again, the second step is what? Yes guys, tell me, second step क्या है यहाँ पे? It is once again the Mitsunobu reaction. So it is going to give the inversion of OH, isn't it? So that gives you inversion of the OH group like this. And it comes above the plane. And the OH comes above the plane. So actually there is this one thing that I need to mention. In your second step that you are having, it is the Mitsunobu reaction, but your nucleophile is not OH directly. What is your nucleophile? It is 4-nitro. It is 4-nitrobenzoic acid actually. And in the presence of PPH3, you are going to get this nucleophile. So the nucleophile is a carboxylate salt. You are not directly getting the modified OH actually. So it is going to be a salt like this, carboxylate salt, and hence after the hydrolysis of the ester that we get. Yes, very good all of you. So after the hydrolysis of the carboxylic ester that you get, your answer is very, very simply option number A. Both of the methyl and both the OH groups, both of these are going to be above the plane. So A is your correct answer. You are getting very similar questions in your exam this time, as well as I expect the same for the Tamil Nadu exam as well, guys. So yes, these were some of the questions that we have done for today. Now I want all of you to be reminded of the same thing, that we are starting our new session from 1st of December itself, because we have this 1 month's time extra. Alright, so we are starting our December session already. So we are going to study from 1st of December to, let's say, end of June till your exam is there. So we are going to study like this, and this is going to be 7th month discussion this time. All the times we have 6 or 5.5 months, this time we have 7 months in hand. So the preparation has to be really, really important and awesome. So June 2021 batch starts from 1st December, in which it's me and Nurul Huda sir, we are going to complete all important topics. all important topics from the complete syllabus. Okay. Thank you, Narendra. Very well, very well. So every month, guys, we are having some free classes. So if you want, you can join up, all the new students. Every month we have some free classes. So what I'll do is, in the next YouTube, or let's say Unacademy special class, I will inform you about the new free classes for all the month, the special class and the YouTube session. Special class on Unacademy website, and YouTube session on the YouTube channel of Unacademy, that is right over here. So we have some free classes every month. I will inform you about December free classes very soon. First of all, we are focusing on the plus classes over here. What are the plus classes? These are courses. These are well made, well defined courses that we have, and we have planned for now. We have planned for the December to March course. These are the 4 months course that we have done till now. After March, we will be doing our revision and practice. So from the mid of April, you will see that new courses are getting launched on revision and practice. This is how we spend our 6 months. Okay, yes, so here let's quickly talk about this. Yes, yes, Aribam, the class is going to be in English. As you can see, all of these courses are there in English only. And me and Nurul Huda sir are teaching in English. If you want, ye dekho, me and Nurul Huda sir, both of us are teaching in English. If you are comfortable with Hindi also, then Sonu sir is taking classes in Hindi. Okay, so if anybody is interested in Hindi classes, then you can join up Sonu sir. He teaches very good as well. Okay, yes. Yes, Swaroop, life science CSIR. Okay, so if you want to follow the life science classes, then you can join Jyoti Kumari ma'am, and yes, you can just follow her once and check out when her courses are getting launched for the life science. Okay. What about physical chemistry? Yes, there it is. Physical chemistry and inorganic is completely taught by Nurul Huda sir, and I am teaching complete organic and inorganic. Okay, so this is what we are doing in this batch course. Alright, so yes, these are all combined courses. You are getting physical, inorganic, organic, everything. Okay. Alright. Yes, so this is it, guys. As you can see, we have 5 new courses which are coming up. ये तो हो गया GATE का practice course. GATE practice course will be there with all the 3 educators. He will be teaching in Hindi, Sonu sir. We too will be teaching in English only. And this is a complete practice course for your GATE exam, where we are doing the previous year question, and also we are doing the new questions, the new pattern questions, since you have the now you have those MSQs question as well. So we are going to plan for that as also. Okay. Yes, Narendra, definitely we study everything together, so I don't think there would be any problem. Okay, how much is the amount for December to June batch? Now, yes, the thing is, if you want to subscribe for December to June, actually what we have is, guys, the CSIR subscription is a time-based subscription. Usually I suggest students 6 month when you have the January to June session. If you have the January to June session, then it is actually 6 month only. So this is what I tell students to join for 6 months. But this time we have December to June. If you think कि 6 महीने करके you have to join this 1 month course also, okay, that is going to take you actually 7 months this time. Alright, so this is going to take you 7 months. If you think that you want to subscribe for 7 months, you will take the 6 month and 1 month subscription. You just add the amount and see first that it is going to cost you around 11,000. Okay, 2,000 and 9,450, exactly 11,550 it is going to cost you. And in that you can purchase a 12-month course as well. So I am not telling you to go with the 7-month or 6-month. It is up to you. Whatever you want to buy, just buy smartly from here, because you see the prices are very comparable. And don't forget to use this code JagritiS, because that gives you a 10% discount as it is shown over here. Second thing is, if you have seen a lot of special classes, then you earn some credit points. These credit points give you further 10% discount, as you can see over here. Okay? Yes. So once again, just one CSIR subscription is going to give you access to all the educators classes, all the educator classes for, let's say, for different timings. If you are joining for 1 year, that is also going to be around 10,000. If you are joining for 6 plus 1 months, that is also going to cost you 10,000. Okay, so yes, buy smartly from here. If you are a BSc student, then you can join up for 24 month as well. This is going to be completely educational for all of you. Okay, so yes, any more doubts that you have regarding the plus classes, regarding the new course, new session? Alright guys, then okay, I just hope that I have answered most of your questions. If you have any more query, you can personally message me on Telegram as well. Okay, so this is what I can do for all of you guys, and this is my personal Telegram channel, CSIR NET 2020. You can join up over there, and also if you are getting more confused, you can personally message me on Telegram as well. All right. So, okay, now I will see you on 29th. Okay, we are having this new strategy session. New strategy session. This is a free session that I'm talking about on the GATE 2021 strategy. Okay, new strategy session on GATE 2021. Once we do the strategy session, then we are going to join up the practice course that starts from 1st of December. So this is the flow. First we discuss the strategy, that how are we going to spend our next 2 months or 1 month, and then we begin the practice. This is what we do. So I wish all of you to join the strategy session. Okay, and then yes, and then we are going to move onwards. Okay guys, very well, have a good day all of you. We'll see you very soon in another video, in another session. Have a good day. Bye everyone.